Jai Gurudev and good morning student. Today we'll take the last part of P block element. This is oxides of other halogen. Other halogen forms oxides in which the oxidation state ranges from +1 to +7. So Cl2O, ClO2, Cl2O6, Cl2O7. These are the other oxides of halogen. Now here the oxidation state comes to +1. Here it will be +4. There is +6, this one is +7. Now, so there are different oxidation state from +1 to +7. The halogens can form oxide. Now, reactivity towards metal. When the halogen reacts with metal, Br2 reacts with magnesium, magnesium bromide is formed. Here one point to notice that metal with fluorine, metal with chlorine, metal with bromine, metal with iodine with respect to ionate character, because the same metal is used in every cases, but here since iodine is larger in size, so it will easily break down. So covalent character size of the anion, so left to means ionic more, it is the more ionic and it is the more covalent. So as the size increases of the anion, covalent character is increases. It is clearly written the covalent character is directly proportional to the size of the anion by Fajan's rule. Now reactivity of halogens towards the other halogen. Now halogen combine to form large amount of interhalogen compounds. For example, XX dash, XX3 dash, XX5 dash, XX7 dash. Here the oxidation state again +1, +3, +5, +7. This is the oxidation state. In one point to be noticed that here X, the first element, must be larger than the second. X is greater than X dash. So it is said that actually X is greater than X dash. In X dash compound, your X is greater than X dash. So that is why IF7 exists, because I is greater than fluorine, but Fi7 does not exist because fluorine is smaller in size than that of the iodine. Now chloride preparation by Deacon's process. 4HCl plus O2 CuCl2 2Cl2 plus 2 water. So this is the Deacon's process for preparation of chlorine. Now there are several reactions of chlorides are there. These things you have to remember. Next is your hydrogen chloride. Now if NaCl react with concentrated sulfuric acid, it is giving sodium hydrogen sulfate and hydrogen chloride. Now after that, one more point to remember, this is aqua regia. It's a mixture of HCl and HNO3 by ratio 3:1. Now aqua regia can dissolve the noble metals such as gold, platinum. So these are the reactions to dissolve the gold and platinum. These things also you have to remember. Oxo acids of halogen, due to small size and high electronegativity of fluorine, it forms only one oxo acid, HOF. So this is, remember, the small size, high electronegativity, absence of d orbital gives one oxo acids of fluorine. This is your HOF. Now chlorine can form several oxo acids. This is the hypochlorous acid, HClO, chlorous acid, HClO2, chloric acid, HClO3, perchloric acid, so HClO4. This is the first HClO structure. Here you remember chlorine can form maximum 7 bonds. So if you want to draw the structure of HClO, so Cl first forms a bond with like that. If I want to draw the HClO2, so Cl first forms the bond like that. This bond is common. Now in HClO, chlorine electronic configuration we have learned 2, 8, 7. So it can form 7 bonds. So here it is forming only one electron is used. So 6 electron left unused. So this is a lone pair, this is another lone pair, another lone pair. Here HClO2 1O 1H is used, another O left. So with chlorine it will form say double bond like that. So chlorine used 1, 2, 3 electrons. So out of 7, 3 electrons are used, 4 electrons left unused. This is used as lone pair. If you want to draw HClO3, then your Cl is there, O oxygen is there, hydrogen, ClOH. Now there are two oxygens left, so one oxygen with double bond, another oxygen with double bond. So the electron 1, 2, 3, 4, 5 electron used, one lone pair left. Another one HClO4. So Cl1, this bond is common, ClOH. So 3 oxygen left, one double bond with O, another double bond with O, another double bond with O. This is a perchloric acid. The 2 electrons, 2 plus 2, 4 plus 2, 6 plus 1, 7. Now interhalogen compound that we already discussed, the halogen combine amongst themselves to form a large number of compound known as interhalogen compound. Now we are taking some reactions where the interhalogen compound is formed. Cl2 plus F2 2ClF, I2 plus 3Cl2 2ICl3, Cl2 plus 3F2 2ClF3. So these are interhalogen compounds. The several interhalogen compounds are formed like that. After that we are taking the group 18 elements. In group 18 we have helium, neon, argon, krypton and xenon, radon. These are the inert gases present in group 18 elements. Now general electronic configuration is NH2 NP6 except helium. They have very high ionization enthalpy due to completely filled orbitals. Electron gain enthalpy is positive due to completely filled orbitals. Atomic radii of group 18 is highest in its period because it is measured by van der Waals measurement technique. So van der Waals measurement means two non-bonded electrons. What is the radius between two non-bonded atoms? So these things you to remember. Physical properties, all of them are monoatomic. Now noble gases are soluble in water due to weak dispersion force or dipole-induced dipole interactions. So this is why the noble gases are soluble in water, because noble gases there is a weak dispersion force takes place. Then out of all noble gases, you remember xenon is found to form real compounds. Why xenon? Why xenon can form real compounds? Due to its low ionization enthalpy and presence of d orbital. Helium, neon do not form compound due to absence of d orbital. Now actually Neil Bartlett first prepared the noble gas compound. Though he has tried with oxygen with platinum hexafluoride, successfully prepared oxygen platinum hexafluoride. Now he has observed that O2, to take out one electron from O2, the ionization energy required is the same to take out the electron from the xenon. So he has, from this knowledge, he to prepare the compound with xenon with platinum hexafluoride, and he can prepare that red color compound of XCPtF6 negative. After this preparation, he has tried with other electronegative elements, xenon with fluorine, xenon fluoride, xenon with 2 fluorine, xenon XeF4. So several compounds with xenon with oxygen and fluorine takes place. So these are the compounds of oxygen and fluorine. So these reactions, all the reactions are important, that is required to know. Now, if I take the electronic configuration of xenon, the ground state xenon is Ns2Np6. And the ground state will be your Ns2Np6. Nd is 0. Now, in the excited state, one electron may jump there. The first excited state, another electron may jump here. This is the, in that case it can form 2 bonds because 2 unpaired electron. In that case it can form 4 bonds, 4 unpaired electron, 6 bonds. The excited state 1, 2, 3 up to maximum is noble gas, and excitation cannot be proceed further. So 1, 2, 3 electron can be promoted to higher shell. So there is 2 bond, it can form 4 bonds, it can form 6 bonds. So if it is formed 2 bonds, so it has 1 unpaired electron, 2 unpaired electron, 3 unpaired electron. If it is formed 1, 2, 3, 4 bonds, it has 2 unpaired electron. If it is forming 6 bonds, then it has 1 unpaired electron. So by knowledge of that, we are going to drawing the structures of several xenon compounds. So actually xenon, the valence electron is 8. So if I want to draw xenon fluoride, so xenon with 1 fluorine it will form bond, another fluorine it will form bond. So 2 electrons utilized out of 8 electrons. So we have still left with 6 electrons. This is linear structure. If I want to draw XeF4, this is, in that square we have put XeF4. Still it is 8 electrons, out of that 4 electron is used. 2 electron makes 1 lone pair here, 1 pair in the bottom, another pair in the top. Then if I want to draw XeF6, so XeF6, F6, 6 electrons are used. Still there is a lone pair left, lone pair you have to show here. So this is distorted octahedral. Distorted octahedral. If you want to draw XeOF4, so Xe double bond O, 4 fluorine atom like that. Still with left with a pair of electron, you have to show it like that. So that's all student in P block element. Thank you.